Guys, let's try this question. And guys, I can read the question first. Use the substitution t equals to tan x all over 2 to show that the integral from 0 to pi over 2 dx all over 1 plus cos x to bracket squared is equals to 2/3. Guys, let's attempt this question. So guys, what we are going to do, we are going first of all to work out this, and this one can be worked out by this what we have here. Guys, let me show you here. We are saying tan x all over 2 should be equal to t all over 1. This is our angle, and so therefore guys, we can also find for cos. So if we look for cos using this triangle, guys, we have derived that triangle from this. We can find cos x all over 2 from this. This one is going to give us 1 over, that is adjacent all over hypotenuse. That gives us that 1 plus t squared, like that guys. So now guys, we embark on doing this question. So let me just write the question first, and then guys we continue. So the question, I can write it here. That is integral from 0 to pi all over 2 dx all over 1 plus cos x squared. This one guys, we are supposed to get our solution as 2/3. So guys, I can start now this question, and this is how guys I'm going to start the question. I will say from the trigonometry guys, we know that cos 2x gives us 2 cos squared x minus 1. Guys, we know that, and so therefore guys, we are going to say cos x, because guys, what we are interested in is converting this cos x to cos x all over 2, and this is what I will do. I will come and say, now cos, for us we have cos x, so we'll have cos x. This is now going to be equal to 2 cos squared x all over 2 minus 1. So guys, what I have changed is the value of this. Now it is a half, so even this one is also going to be a half. So guys, from there I will come now and replace for my equation here. But before I do that guys, I will come and say t, this t is equals to tan x all over 2. So let me find my dt dx, because here guys I'll have to replace the dx with t, and so I have dt all over dx. This one gives us a half, because of this half, sec squared x all over 2. And so therefore, the dx will be equal to, we shall have, if we bring this dx here and this we bring it here, we shall have dt like that all over, we can bring this, that is sec squared x all over 2, can extend that line, and then we bring this 2. This 2 now is going to come at this place here. So this one gives us dx. So guys, we continue. Now guys, we come and replace for cos x. So that guys, we make cos x to be cos x all over 2. We'll come and write our equation yet again here. 0. Here we have pi over 2. Instead of writing dx, we can write this. We can replace that with 2. Here we have 2 there. And then we have dt. Guys, we write here sec, of which, guys, our sec is 1 all over. This one is supposed to be, this is supposed to be 1 all over cos squared x all over 2. So guys, when I write all over, it means that now cos is going to come here. We shall have cos squared. We shall have cos squared x all over 2, like that. Then guys, we come here, we now come and replace our cos with this. So we shall have 1 plus cos is going to be 2 cos squared x all over 2, can extend this line, minus 1. And now guys, this is now going to be squared. So we square that, guys. So we shall have now 2. You have the integral from 0 to pi over 2. Here we have cos squared x all over 2 dt. And guys, here at the denominator, we can cancel that one and that one. We are left with 2, and 2 squared will now get this as 4. Then here we are left with the cos squared x all over 2. Now that it is squared, this one will now still have another cos squared x all over 2, like that. It will be like that, guys. And so guys, we can cancel one of them. We can cancel that. We can cancel that. So we are left with 2 all over 4 integral from 0 to pi over 2 dt. And then guys, we have cos squared x all over 2. Now guys, we can now replace with this, what we are having here. That is now cos x all over 2 equals to 1. That is, we say here cos, this one is given by 1 all over 1 minus plus t squared, like that. So this one is given, this cos squared x over 2 is given by that. Because when you square this, guys, when you square this, you get 1 all over 1 plus t squared. We remove the square root once this is squared. So guys, that's what we are going to replace with. So we replace with, now this is going to be 1 all over 1 plus t squared. This is now going to be here 1 plus t squared, like that. So guys, finally we are going to have 2 all over 4. You integrate that, we shall have t plus t cubed all over 3. Now from 0 to pi over 2. With that, guys, when we put, using this, our substitution, when we put x equals to 0, our t then should be equal also to 0. That is, if you find cos tan 0, will give us still 0. When x equals to pi over 2, and pi over 2 is supposed to be, is equal to pi over 2, t gives us 1, because this one is now going to be pi over 4. Tan pi over 4 gives us 1. And so guys, we come and now replace for our figures here. So we shall have 2 all over 4. If we press 0, we shall get everything to be 0. So now guys, we come and replace here for, this one has changed now from 0. This is 0 now, and this is now supposed to be 1. So we can cancel that, we can cancel also that. So when we put 0, it is 0. When we put 1, we shall have 1 plus 1 all over 3. So this one gives us 2 over 4 multiplied by, that is 4 over 3, like that. So guys, you can cancel that and that, and your solution then is going to be 2 all over 3. So thank you guys for listening to me, and here is the answer, guys. So thank you, bye bye.